extraordinary phenomenon in space captured by spellbinding new image from the James Webb telescope. The universe is full of beautiful wonders like this. The universe truly is wonderful, and the James Webb Space Telescope just gave us our best views of one yet. The object in question is a star around 5,600 light years away, and Webb's infrared eye has picked up an extraordinary detail. It's surrounded by what appears to be concentric rings of light radiating outwards. While Webb's characteristic diffraction spikes are not real, those concentric rings are, and there's a wonderful and fascinating explanation for them. The star is actually a binary pair of rare stars in the constellation of Cygnus, and their interactions produce precise periodic eruptions of dust that are expanding out in shells into the space around the pair over time. These shells of dust are glowing in infrared, which has allowed an instrument as sensitive as Webb's MIRI to resolve them in exquisite details. The full image processed by Judy Schmidt, as we can see. The star is what's known as a colliding wind binary, consisting of an extremely rare Wolf-Rayet star called WR140 and a hot massive zero-type star companion, another rare object. Wolf-Rayet stars are very hot, very luminous, and very old, and at the time of their main sequence lifespan. They're significantly depleted in hydrogen, rich in nitrogen or carbon, and losing mass at a very high rate. Zero-type stars are among the most massive stars known, also very hot and bright. Because they are so massive, their lifespans are incredibly brief. Both stars are in the WR140 system, have fast stellar winds blowing out into space at around 3,000 kilometers or 1,864 miles per second. Both are therefore losing mass at a pretty furious rate. So far, so normal for both stars. Where it gets interesting is their orbit, which is elliptical. This means the stars don't describe nice, neat circles around each other, but ovals with a point at which they are farthest apart from each other, that is apastron, and a point which they are closest to each other, periastron. When the two stars enter periastron, close to each other, a distance about a third greater than the distance between Earth and the Sun, they become close enough that their powerful winds collide. This produces shocks in the material around the stars, accelerating particles and generating energetic radiation such as X-rays, and these colliding winds also induce episodes of dust formation as the material in the colliding stellar wind cools. This process can be seen in the animation, showing what the system would look like from the top down. The dust is a form of carbon which absorbs ultraviolet light from the two stars, and this heats the dust, causing it to re-emit thermal radiation, which is what is observed by Webb in infrared wavelengths. The dust is then blown outward by the stellar wind, resulting in the expansion of the partial dust shells. They expand and cool as they are blown outward, losing heat and density. What we're looking at in Webb's image is a bit like a series of bubbles. The edge of each dust shell is more visible because you're looking at a denser concentration of material due to perspective. And because the binary star's orbit has a 7.94 year period, the wind collision and dust production occur like clockwork every 7.94 years. This means you can count the rings of the nebula around the binary like tree rings to determine the age of the outermost visible dust shell. Around 20 rings are visible, which means you can see around 160 years worth of dust shells in the Webb image. The most recent WR140 periastron was observed in 2016. Webb's observation of WR140 was requested by a team led by astrophysicist Ryan Liu of Japan Aerospace Exploration Agency Institute of Space and Astronomical Science. They're preparing a paper on the observation, so it's possible that we're on the brink of finding out something new about this fascinating, crazy star. This is by Michelle Starr, Science Alert on Collective Spark. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.